whether there should be greater gun controls, et cetera, right? Pretty tough argument to make, as rational as it may be, in the face of the shooting. But I suspect, I haven't heard any data, but I suspect that we'd see similar things here with guns and deaths of children and swimming pools, or pick some other thing, car accidents, something else, where we'd see probably a lot more deaths compared to what guns do. But it's a neat insight there on the hazard versus the outrage, and kind of our human condition that maybe tends to not look at the rational facts that are there about it until maybe things settle. Obviously, I think the NRA, strategically anyway, did the right thing to even hold off comment, right? It's not maybe even appropriate to start talking about the rational aspects of the facts about guns when everybody can think of nothing else but these little kids that got blown away, which was totally tragic and sad. But what's the appropriate policy response? That might be a different question, a different answer. Okay, so got your homework, and I noodled a lot. I want to share my noodlings with you. That tax question, number 19, the one we kind of started discussing. I think I'm right, and I don't like the answer key. So, let's see. Pass that over to Rhiannon. So what I want to do is kind of walk through my logic. I even wrote up a couple simple little equations to just kind of prove it to myself, to make sure everything was lining up okay, and look at the answer as well. So here's the answer. See, I do my homework on pieces of paper just like you guys. Sure. You know, I don't want to spend a terrible amount of time, but I do want to show you a few things here. So I'm going to pull this up on the overhead. So we had a tax and a subsidy of the same amount, and the answer key said that the price went down, right? And I was kind of confused. For sure, I was able to kind of reason out that answer, but it didn't seem to be the most clearest answer. So that's why I thought, if nothing else, I'm not even completely saying that for sure it's wrong, but there's not enough information to for sure tell it's right. So I won't want to see you give that answer on an exam, because I would probably mark it wrong. So we got to learn how to at least justify our answers a little bit better. Let's see what's worth showing to you here. This is kind of a mess because I really did just kind of doodle it. I wasn't even thinking I was going to show you, but now that I looked at my little picture, I think I'll do a combination of both. So think about the tax as a wedge, as well as a shift, I think, is one thing. The shifting part helps conceptually when you alter the equation on what you're doing. So one thing that you weren't required to do was, and I can't remember if there was another homework problem or something in the book that showed you how to implement the tax. So here's the demand equation that I just made up. I just said 10 minus P, something real simple. And then if there's a tax that's going to, on the consumer, that's going to raise the price by $1. So now it's 10 minus P plus 1, right? And then the subsidy at the same time, I just said, let's suppose we got a supply function 2P, it's just 2 times P plus 1. So you distribute that 2 through. All right, so then I set the equations equal. I even made a little mistake down here at first and started calculating out what this is. And at the end of the day, it came back to the picture that I thought it was, where it was right on top of where we were, leaving the situation the same as it was before, with a couple exceptions. So the answer key in number 3 said, what was it? It depends on the elasticity of whether the quantity changed. Wasn't that part B? What did you guys basically kind of mimic that? And so I thought, oh, well, maybe it is something to do with the elasticities. I didn't think so, but I was able to use our economic logic here. So suppose I just said, well, let's take a fairly steep supply curve, more inelastic, and a relatively flat demand curve. And so when we impose the tax, the consumer's price goes up, right? But now in this case, the consumer's price doesn't go up very much, right? So even though we're taxing the consumer, their net price with the tax ends up going up just a little bit. In other words, the burden of the tax ends up being shared by or borne by the supplier because they are relatively more inelastic, which is the foundation that we had before, right? So the shift of the tax burden is on the producer here. And so PC, which I kind of got down here, PC goes up by a little bit. Now, when the subsidy comes in, the supply curve shifts to the right, like he showed in his diagram, or the kind of the fake supply curve is off here to the right. Or we can think about it as the wedge coming in between the old supply curve and the tax demand curve. There's the subsidy wedge. And so with that subsidy, the price that the producer gets is at the top part of that wedge. So the PP, the price that the producer gets, is back up to here. And then the neat thing is that the consumer's price after the tax floats back down to there too, right? Because the tax dropped it down to here, that floats it up and it comes right back. So we are back to the same level that we were before. Quantity stays the same, which is what I had thought happened if we have it under these circumstances. With the application of both the tax and the subsidy, the quantity is going to stay the same, and the price to the producer and the net price at the cash register to the consumer is all going to be the same. We're going to be right back at that price. So I wanted to see how your, he mentioned the word equilibrium, which always gets kind of a little strange when we start talking about the tax, because you've got the producer getting less than what the consumer does in the case of a tax, right? That's what the whole wedge concept. So what is equilibrium price? Well, there's a price paid by the consumer, which is really the market clearing price that's out there in the marketplace, and then the producer nets that amount. So to the producer, they're really getting PP, but the market out there in the marketplace, it's this PC price.
So with this one, with the new, since there's the supply and subsidy and the demand for tax aren't the actual current, are they? I'm just
That
so because like so basically what you're saying is like the price like that would be where the subsidy and the tax cross isn't necessarily the price of the
so where the subsidy, kind of the fake supply curve and the fake demand curve intersect, tells us the quantity.
But that's not the price.
Right.
Okay.
Yep.
So that's why the price doesn't necessarily move down.
That's right. Yep. It ends up being and again, if we kind of told the story sequentially, which isn't quite fair, what should be taken here is that this is done simultaneously, right? The tax and the subsidy are all kind of happening at the same time. But if we do the tax first, consumer's price goes up, not down. And then after we apply the subsidy, the consumer's price comes back down. And that's where I couldn't quite tell from that answer key if that's what they were saying, that that price comes out. It certainly wasn't real clear. John?
So because the money raised from the tax is going basically directly to the subsidy, this is really a waste of time. There's nothing happening.
That's right.
Okay.
It's dumb because what the model's not showing is the government expense of facilitating the tax and transfer program, right? So that's not being modeled here. So there's really waste. There's a deadweight loss that's not being shown in this, what we call now a partial equilibrium analysis. So I think I talked about that last time. One of our later chapters is called general equilibrium, where we start to take into account effects around the whole system. Like what are these, how do things get displaced? And so when you take a snapshot of one particular market at one particular time, we're missing some information. Okay, anything else?
Would the price to the producers be the one that decreases? Just because because it's like the consumer, I
Not
can
in the
see, like,
simultaneous
their
case.
price.
Not in the simultaneous case, I guess, for a quick answer. So without any government intervention, we're here, right?
Yeah.
And if we simultaneously put into place both policies, we're here. And so there's no change to the producer's price.
But don't the producers get the subsidy, so they don't have to? They don't incur as much of a loss. It doesn't cost them as much to make the goods.
Yes. So they're still getting their. If we analyze their consumer and producer surpluses, there's a difference. Maybe that's what you're getting at. Because producers are getting this chunk. So we did alter the consumer and producer surplus.
Okay. I got you.
Okay. And
Is it right that like the tax moves the demand to the left?
Yes. Yep, just like this. So the demand curve with the tax is kind of, I like to think of it as a shift down by the amount of the tax. I can't remember if it was this book that says kind of an inward shift, which is fine. I mean, it's kind of telling the same thing, but the actual shift down is by the dollar tax. So I like to think of it as a shift down because that gives you quantitatively exactly that edge. The edge of the wedge is the amount of the per unit tax. Okay?
So then, on C, where they ask the comparison,
Yeah.
so then what's the comparison between the two different things?
So then in that one, what did he say? The quantity doesn't.
I can't remember.
Yeah, it seemed messed up because that one, I can't say I completely went through all that, but if you take the tax revenue and divide it by the number of suppliers, I think it's a lump sum transfer to them. It's not a decision of production any longer. It's just a gift that they're getting, which is different, right? Than the per unit subsidy. They're like, in their mind, they're thinking, okay, every unit I make, I get $1 more. That's different than,
The same amount.
right, they're just getting this lump sum amount back. So to me, with that one, the tax kind of dominates, sets the stage for the QT being the quantity exchange in the market after the tax being something less than where we were before. And so it is materially different with the quantity being less.
The subsidy maybe a little smaller because
Yes.
like per person.
Yes. Yep. Because, yeah, the subsidy would be out here otherwise.
I was just going to kind of continue on from that, I guess. I mean, since we have all vendors being identical in this,
I can read that.
yeah, that's the one of the stipulations that all vendors are equal, so we got that much of a change.
Yes.
Okay.
And I say yes with a 90% gut check on that. And I think you'd need more details in this model to make it look different. Like you'd have to have a supply function to say that, oh, you're getting some unknown amount back into the system from taking the tax revenue and dumping it back, but it's still a flat amount, not directly tied to your own production level.
Yeah, I guess it would go off QT because it would be you would have the market basically incur a QT before you get your money back.
Yeah, that's right. Yep. That QT dictates how much you're getting back, So in some supply function that I'm imagining, or it would actually be a revenue function, right? So you're selling this amount and you're netting this price. So that's price times quantity is your revenue, but then you're getting this lump sum plus this extra chunk that is not dependent upon your decision making alone, but the aggregate decision making of the market, because there's more the other suppliers, whoever's out there.
It's basically like a working perfect competition.
Yeah, and you're getting this flat chunk back, which is not a variable amount under your control. So I don't think it would change your decisions at the margin. The supply cost is the marginal cost curve. So I didn't want to take the time to work out all that, because I think at the end of the day I'd probably be just making more and more assumptions to make it work or change things. So, but I'm pretty confident that the quantity, it's materially different, and this is an important thing to take away from all this, is that deadweight losses occur when we move away from what was allocatively efficient to begin with. So marginal benefit equals marginal cost here. That's the allocatively efficient quantity for society. Any other quantity would end up creating some sort of deadweight loss. That's the way that stuff works. Unless there's externalities, which we'll get into later. But assuming no externalities and no problems like that, anytime you move off, anytime you've designed, you've altered, you've distorted the market system under these assumptions, and you've moved off the quantity, there's some sort of deadweight loss somewhere. You can't just create welfare out of nothing. Welfare comes from the quantities, and this is the allocatively efficient quantity to produce. Okay. I guess I'll just video mute. So, consumer preferences, difference curves, and utility. I want to kind of tighten up what we started on yesterday with the consumer axioms. I left a few off. I'm just going to follow more closely here the language that your book has. So number one is the ability to rank, which they call completeness and rankability. The ability to rank preferences. Bundle A is preferred to bundle B is preferred to bundle C. Number two, more is better than less. Or at least no worse than less. So more is preferred to less. Number three, we didn't talk about yesterday, is transitivity. So this would just be if we've got bundles. We did A, B, and C last time, right? Just for a simple little example. So it's okay if I just put if A is preferred to B. Let's just put P R. We used to have some notation that I can't remember. A is preferred to B, and B is preferred to C. Then what do we know? A is preferred to C. Okay? So that just means we can deduce some information if we have data on A relative to B and B relative to C, then we can infer information about A relative to C. Preferences are transitive. And then the last one the more, I'm going to kind of paraphrase this. I don't feel like writing out that whole sentence, but the more you have of a good, the more you have of a good, the less you are willing to give up of something else. I guess I'm getting wordy anyway. I don't think there's any other clearer way. Well, I got one clearer way, but I know why they did it this way. But willing to give up of something else to get even more. What's that?
I was just curious if it was transit.
Transit. Did I spell that wrong? Yeah, it looks like I'm missing a T or something here. Transitivity. There we go. Perfect. Transitivity. So I kind of, in a way, don't like number 4, just because it's more wordy than it needs to be, and there's kind of some fancy math words that you can use that shorten this up. But does this ring a bell for you at all? The more you have of a good, pizza, let's say, the less you are willing to give up of something else, let's say beer, to get even more pizza. What does that sound like from principles class? Yes, it is. Something about the shape of the indifference curve, too. It's a law. Yes, good. Diminishing marginal utility. That's exactly what it's saying here. So the reason the author, I think, put this in here at this place is that they didn't really define marginal utility yet. That's like on the next upcoming pages. But this is really the law of diminishing marginal utility. Okay, so that's kind of our 4 axioms of consumer preferences that we're going to be working under. And I want to characterize the problem first with utility maximization. So the consumer problem that they face is to, putting it in words, maximize total utility maximize total utility subject to a budget constraint. So a couple things to note here is that the utility function, utility is dependent upon consumption of goods and services. Now, I just want to kind of put out there right away where economists kind of get, honestly, I think some academic economists I've come to learn get kind of confused sometimes, is not being general enough with what we mean by goods. So goods could be leisure, how much extra time you have on your hands. Goods could be holding your new niece or nephew, the little baby. So I'm being real general here with what a good or service, what can be plunked into that utility function. So for, you know, as we work through the chapter, we're usually throwing in beer and pizza or peanut butter and jelly and tennis rackets and kind of consumer goods. But I want you guys to be thinking a little more broadly about what goods are. So utility is dependent upon consumption of goods and services. Goods can be just about anything that increases utility. So leisure is something that labor economists pay a lot of attention to. So leisure, holding new baby. Now, if you're doing an activity that decreases utility, what do we call it? Instead of a good, it's a a bad, basically, a bad. That's right. And so we are thinking about things in our utility function that we would be acquiring. You'd be avoiding bads and getting goods, right? So that's what we mean by goods in general. All right, so the budget constraint the budget constraint is let's see, I want to be a little bit is mostly, I gotta be a little careful here. There's one circumstance is mostly defined by the market. Through prices. So the budget constraint is mostly defined through the market by prices. So in other words, we don't set the price of what's on the shelves at Walmart. We're subject to those prices, right? So that ends up then being part of it. The thing where I wanted to be a little bit careful about is on the income side, we might be subject to some degree to the market rate for a bachelor's degree and going into this type of job when you guys enter the labor force, and you're going to get $40,000 a year for the type of skills that you bring to the table, right? So it's kind of a market rate determined there. But I wanted to be slightly careful there that your income is also somewhat chosen by you on how many hours you work. So it can also be phrased as a choice variable. That's where the labor economists come in that if you choose to work more hours, you by default have less leisure because there's only 24 hours in a day. So we have a time constraint that we face when we bring this model to kind of another level where we're like, okay, now we're making decisions on how much time how much income should I have, depending on how much hours I have. Well, leisure's in my utility function too, so now I have a balancing act at the margin of how many hours should I work to buy market goods versus time holding the baby and watching TV and doing other things that give me utility. Okay, so let's go ahead and write out this. This one's a little, we'll come back to defining the utility function. This one stays very similar to what we saw in principles class. So we've got a certain amount of income, and what does that constraint look like? What does the equation look like? Searching this, make sure I stay somewhat close with notation on this because it can go a couple different ways. Anybody remember? I'll give you a hint. You can't spend more than what your income is. How does that lay out with your equation goggles on?
Your income equals the price of the good times the quantity of the good plus the price of the other good times the quantity of the other good.
Good. All right, so the price of, let's go beer times the quantity of beer. We're going to use a capital B for the quantity this time, just to stay in line with the way your text does it too. So the price of beer times the quantity of beer plus the price of pizza times the quantity of pizza. Which pizza, P is probably a bad one, isn't it? Maybe we got to make a special P here. PZ, pizza. We got price of pizza down there. All right, so this then represents your total spending or expenditure. And that's got to be mapped up with your income. In this equation then, if we're under the scenario of you make $40,000 a year because that's what your employer offered you, the salaried position, so you're under a salary situation, what are your choice variables? The quantities, right? So the quantities of beer and pizza are your choice variables. These are determined by the marketplace. And in this case, the income was determined in the resource market as well, your salary. Okay, so that's the budget constraint and utility, or utility description. Let's put a little more teeth on the utility function now, something we didn't do in principles class. So, before I do that, I want to say something here. So, the 4 axioms of preferences imply the shape of the utility function. It's going to be an increasing function in its arguments. So it's an increasing, and I guess I'll throw in this word monotonic. Which allows us to it's related to the ordinal part of the description. So an increasing monotonic function, it starts at 0 at the origin. And that last axiom tells us that it's increasing at a decreasing rate. So since I have a couple of you here on the calculus track, increasing function, what does that tell you about this when we start taking derivatives? So if I give you a function and it's an increasing function starting at 0, what is that first derivative? What's the sign going to be? Positive sign. And second derivative? Negative. Increasing at a decreasing rate. Okay? So that's a couple things there. I just thought I'd point that out, that's some of the connections here for that. All right, so obeying these rules, one won't totally obey the rule. But let me put one up here that does. So suppose that the utility that a consumer has from consuming beer and pizza is equal to B to the 0.6 power times P to the 0.4 power.
So that's utility up by beer pizza.
Yep. Quantity of beer, quantity of pizza. This is our functional form, more generically stating that my happiness is dependent upon quantities of beer and quantities of pizza. The underlying preferences tell me that my happiness is increasing in both of these arguments, and we've got this increasing at a decreasing rate thing going on. Okay, so it kind of helps define what that creature looks like. So can you tell me anything about preferences at this point, given those numbers? Okay, why do you say that?
It's like a higher exponent.
Okay, because of the higher exponent, right? Now, the one thing where it could get a little slippery is this one pizza, a full pizza and 6 ounces of, I'm sorry, this is my beer. So this is a full pizza and this is 6 ounces of beer. So we could screw around with the units where we wouldn't quite get that story. So assuming we've kind of normalized it, I am wanting to go with your gut reaction, but I wanted to point out that units thing we kind of got to be careful of as we work through some of these. You're right. So if I have 1 and a 1 beer and 1 pizza, I get 0.6 contributed to my utility from the beer, and I only get 0.4 units of satisfaction contributed to my utility from pizza, right?
That's per unit.
That's on a per unit, kind of normalizing again. Didn't know if it was one. So let's just write that out here. If beer equals 1 and pizza equals 1, then beer contributes 0.6 to my total utility, and pizza contributes 0.4 units of utility. That's our utils to my utility. If we were consuming at the point where I had 1 beer and 1 pizza,
Yeah.
I'm just plugging and chugging a 1 here and a 1 here.
Alright, 1 to the 0.6.
Oh, you're right. I said that wrong. That would be in changes of the utility, which I haven't gotten to yet. So, trying to think if I should.
So this rate it would be 0.6 times B.
Yes.
P times
If the change in beer equals 1 and the change in pizza equals 1, so 1 unit change gives you that result. So I'm just going to put a little delta in there, and the change in beer gives us that little extra bump in utility. Now, again, partial derivative of that. Curtis, I'm going to put you on the spot, Mr. Math Guy. Partial derivative of this function with respect to b. Yeah, just what would the answer? Yeah, what would the answer be? Yeah, no, I just want you to sit there and be silent if you could, and we will predict. We will develop a model to predict what your answer would be.
It'd be 0.6 to the negative 0.4.
Okay, so we got if we take a partial derivative, with this, then we get 0.6 is the parameter on it. And that's where we get the 0.6 change off of this. So it's the slope of a curve is where this is going to come from here in a second when we think about the changes. It'll be the slope of the utility function at a point, but it's really a surface. This is the 3D thing. Remember my 3D thing? Sam didn't have we got the pizza axis here, the beer axis here, the utility axis here, so it's a three-dimensional graph, and we're calculating the utility at some combination of those two things, and this utility function comes up over the class like a big canopy. Yes?
So when you said something about partial derivative, does that mean you're just taking the derivative of b and not? Okay,
Yep.
so that's what.
When you take partial derivatives or whatever, like in dB, you count the p as a constant.
Yeah.
Okay, so.
Yeah, I'm getting.
You'll see that when you guys work your problems, those of you who are doing that. So I don't want to spend too much time on the calculus, but it all ties in nicely because now I want to come back to the basics here of marginal utility. So marginal utility, MU, is the change in total utility from a 1 unit change in the good. And you're doing the same thing with your partial derivatives. You're holding constant the other term. So this is why that plays in with the p just falling away. So the marginal utility of beer is equal to the change in total utility from a change in beer, just like we did in principles class. And that's the quantity of beer, yeah. And I'm just staying consistent with the book now.
So now we're going to take out the Q.
Yeah, we're just taking out the Q. Okay, and the marginal utility of pizza equals the change in the utility function, the change in total utility from the change in pizza, from the change in the unit of pizza. All right, and so finally we got the marginal rate of substitution, the MRS. This is the willingness of the consumer to trade one good for the other. And it ends up being the slope of the indifference curve. This is then an internal willingness to trade one good for the other. So the marginal rate of substitution of beer for pizza is putting these two things, I'm going to shorten this to change in U, so putting the ratio of the marginal utilities on top of each other. Maybe I should have did 2 steps there and showed marginal utility of beer over the marginal utility of pizza. If you haven't quite gotten to this point, you might want to write this over there, but because this notation is important, so I want to highlight that for you as you read this in the text and look at problems. The marginal rate of substitution of beer for pizza is marginal utility of beer on top, marginal utility of pizza on the bottom. The reason that's going to seem weird is that now when we come here, if we invert the denominator, multiply it times the numerator, we get the change in utility over the change in beer times the change in pizza over the change in utility. Change in utilities cancel out. It's the slope of the indifference curve. But the rise over the run has pizza on the vertical axis, beer on the horizontal axis. So I'm saving that part for last. If we have an indifference curve with some utility at 100, pizza's being measured on the vertical axis, beer is on the horizontal axis. And the slope of the indifference curve, the rise over the run, is that marginal rate of substitution. It's the slope of a tangent line just kissing the indifference curve. And of course, we see the law of diminishing marginal utility reveal itself in that the slope is different at different points, which is axiom number 4 that we had when we started. So, slope of the tangent line is change of P over change in B equals the marginal rate of substitution of beer for pizza.
Could you just use the marginal utility as the, like just divide the marginal utilities and that would give you your slope as well?
Yes. So, yes, you can take that, if you get a number here, then you just take those two numbers and divide. But what you got to be careful of is the marginal utility of beer is on top here, but that's not the rise of the run. It's always the inverse. So that's the part that I struggled with, always having to remember, oh crap, is it this one on top or this one on bottom? And you just got to memorize that. And just remember that this is the reason. If you remember this formula, this is what always saved me sometimes in graduate school, thinking about the slopes and how that works graphically.
I guess so, like, for this one, like, with us, did we just kind of decide that beer was going to be the X? Like, how do you, like, if you were looking at it?
I let it play out. So now so if I had given you a problem that said beer's up here and pizza's down here, you'd need to flip them. And I said, what's the marginal rate of substitution? And you're calculating a slope, then you'd have to make sure that you're staying in line with that.